So, thanks for sticking around and not falling asleep on me. Not yet, right. Well, I don't have any cool animations or videos to show, but hopefully this will work. So yes, talking about new advancements in oxidation stability and also some electric vehicle fluid testing equipment that is new to the market. Okay. All right, so before we get into that, I do want to have some introductions as to the Savant Group. The Savant Group is made up of 6 companies. Savant Laboratories is an independent testing lab and research and consulting group. The 2 instrument manufacturing companies within the Savant Group are Tonnis Company and King Refrigeration. And we have a global engine oil database company that collects engine oils from the marketplace and performs tests on those and publishes that data for subscription basis. So you can see the test results of the oils from the marketplace. And we have a machine shop that we purchased in 2019, acquired them, and they service the instrument manufacturing companies of Tonnis and King, vertically integrated with our own manufacturing facility, as well as CQA, Center for Quality Assurance, which is a licensing program. They implement and develop and administer licensing programs for OEMs or OEM-type fluids. And some of those include the Chrysler FCA ATF Plus 4, the NLGI HPM program, High Performance Multi-Purpose Grease, the Top Tier Fuel program, as well as the new IFC specification. CQA administers those programs. And we are located in Midland, Michigan, which is a small town, and the world headquarters also for Dow Chemical. So we share the city with them. Ted Selby is the founder of our company, and he invented many of our instruments that we have today, and we have further advancements since then. But he passed away in 2022. But about 3 months before he did pass away, he had his 58th patent. So that was, he'd worked all the way till the end. So looking at Tonnis and King, our philosophy is we serve our customers' needs by producing the finest quality available instrumentation that solves specific problem areas in the industry that customers have. They come to us through Savant Laboratories many times for problems that they have, and we develop techniques and solutions for them. We also perform training and consultation. We also serve the industry by producing these bench tests that have high correlation to engine tests and field data, and that solves critical information, has critical information to the industry and for the customers that need them. So just a quick review of the innovations that we have over the years. We developed the high temperature, high shear tapered bearing simulator back in the early 1980s that started Tonnis Company. And we have 2 different models, the 2100E and the 3000 model. We developed the Scandium Brookfield low temperature pumpability and gelation index test. It's used around the world. We developed the first foam air bath as opposed to the liquid bath for foam tendency and stability. And also the first non-liquid RPVOT that we're talking a little bit more about a few minutes from now. Also, we innovated the NOAC test to move away from the toxic woods metal back in the mid-1990s. And we also have the ability to tune the instrument to the laboratory environment, which is very user-friendly for customers. Also, we developed the TIOS test, which is for high temperature deposit control. There's 3 different test methods associated with the TIOS, 33C, MHT, and the new TIOS Turbo, which has D8447 test method. And also a multi-temperature, multi-purpose liquid bath for running many different low temperature tests. So one-stop shop runs many different tests. Our new instrument that I'll be talking about as well is on the electric vehicle fluid side. It's the TANUS TAN-EV conductive deposit test, the CDT, and the WCT, the wire corrosion test. On the King side, the blue instruments, we developed the SimAir technique for the Brookfield liquid bath for low temperature pumpability, and also an innovative mini rotary viscometer, which moved away from the external chiller bath and tests for low temperature pumpability and yield stress, and that holds 10 samples at one time. So some of the industry specifications that we're involved in, we're very highly involved in SAE, J3200, and the J300, as well as the new J3200 for EV fluids, along with API, many tests there, as ILSAC as well, many tests in the ILSAC specification, and several OEM individual specifications, as well as automatic transmission fluids, industrial oils, the steam turbine, gas turbine, power generation facility, as well as many in the China National Standard as well, GB and the new D1 specification, and some new gasoline and the EV specifications that are coming on in China. So as the engine oil side, with the OEMs, this is we have actually 7 instruments that are included into those specifications. Our distribution network around the world, over 50 distributors worldwide, and we sell to over 70 different countries, so pretty well spaced. We have our partner with us for Malaysia and Booth 57, IPSA, IPSA. They sell and service our products here in Malaysia. So let's go into the topics of discussion today, and that is a new model of our quantum oxidation tester, and then the new tests, the CDT and WCT. Start off with the quantum RPVOT test. This is our older model at the top and our newer model, the Quantum Pro, that I'll talk about. But first, let's talk a little bit about introduction for those not familiar with RPVOT, the rotating pressure vessel oxidation test. It was originally designed to simply compare inline samples of turbine oils. Well, later the test developed into a testing fresh and in-service turbine oils, as well as engine oils. And this test eventually developed limits and is in several specifications for the power generation industry. Here is the primary test parameters for D2272, which is the RPVOT test for turbine oils, and is used to analyze and predict the turbine oil life. So it's a 50-gram sample, heat is 150 degrees C. You pressurize it 90 psi. As temperature increases, the pressure increases up to about 190 psi. Use a copper catalyst coil with water, and then you rotate the beaker at a 30-degree angle, and you monitor and record the temperature and pressure. And as pressure drops, according to the method, 25.4 psi, that signals the end of the test and gives you a break point. And here's an example of what the graph would look like. You have your temperature at 150 going across, and then as your pressure drops, then you just calculate the amount of time that takes. And it's in minutes. Sometimes it'd be 2,000 or 3,000 minutes, or it could be 400 or 500 minutes, depending on the condition of your sample. It's a condition monitoring tool. So the RPVOT bath historically has been a liquid bath utilizing high temperature oil, like silicone oil. Well, obviously silicone oils at 150 degrees C can be hazardous and very expensive to replace as well, because these systems are about 30 gallons they have been of silicone oil. And also they have multiple pressure vessels, so they have to add and remove them to this large liquid bath, so it's quite messy and also smelly and time-consuming to repair. So we came up with, about mid-2004, 2005, we came up with a much safer way of running this test, and that was by eliminating the liquid bath. By having a single position dry cylinder, heated stainless steel oxidation pressure vessel with transducers, and the same glass beaker is placed into a magnetic cup that then lowers down into the reactor and is spun at 100 RPM by a rotating magnet coupler. And it has a convenient front-loading sample loads and oxygen charge and valve release. And you don't really need to have these in a hood, so they can be safely used on the bench. There's just an external a hose as you vent your oxygen to a hood or a vent nearby. You don't need to have it in the hood. So this has really innovated the RPVOT test, and we sell these all over the world. And they're designed for either single bench, single test, or you can put them side by side with the computer, and then that with the computer package which controls or monitors and records the pressure and temperature of each individual unit onto one computer. What this instrument can also do is run the grease oxidation test, D942, by using a special tipping rack that we patented that allows the quantum to be placed inside of this metal rack, which then moves it up to a 90-degree angle because the D942 method requires a reactor to be vertical as opposed to 30-degree angle. So we just tip the unit up, and now your reactor's vertical. So that allows the D942 test to be run. So industry status on the quantum is it's fully incorporated in the D2272 RPVOT method. It has its own SHT method. The D2112, it also is used for D2112 testing, which is oxidation stability of insulating oils and transformer oils. And then also the TFOUT test, D4742, that's used at 160 degrees C on engine oils. And then, as I just mentioned, the D942 grease oxidation. So the quantum can be used for many different test methods, just with a few minor tweaks and changes of temperature and positioning. But there's one other thing the unit can do as well. Because it's a dry bath, you have no liquid bath to submerge the reactor into. You can actually use it for advanced research because you can extract small amounts of sample during the oxidative test periodically and then run other tests on it like an FTIR, so you have a complete analysis of your oxidative process of your oil throughout the test. So liquid baths will not allow you to access a sample that's in the bath. The dry bath allows you to do that. So the Quantum Pro is our new model, which we have on display here. We're introducing this year, and we'll be shipping later this year, but it is now available for purchase to replace the older, the original Quantum 1.0 version. This is a Quantum Pro, or 2.0. And what we've added to it is an auto fill and purge system. So it automatically fills it and purges it to 3 times, and then moves to the 90 PSI and starts your test. We have integrated the water calibration and the sample temperature probe. That's integrated now into the instrument. And also has a live table and graphs associated with the test data with each oil that's run. And USB ports for transfer of records to flash drive or to PC, as well as automating it for over the Ethernet to go into your SLIM system or your LIMS system. We've also been able to save about 20–30% of power usage with this Quantum Pro versus our original 1.0 Quantum instrument. And once again, the Quantum Pro is also included into the D272, used for D2112. It'll also be used for TFOUT and for the D942 oxidation test. So that covers the upgraded instrument, new model of our Quantum. And like I said, we have that on display. The other instrument that actually is new and has been presented several times, my colleague Greg Miller has presented at FNL Asia in Vietnam, and he's been many different places around the world presenting this along with Lubrizol, these two tests, because we partner with Lubrizol, and they actually won the SAE Innovation Award. Lubrizol and also my colleague from Greg Miller, we work quite closely with them to further refine and develop these tests and bring them. Now we're responsible for bringing them to the market. So that's the conductive deposit test and the wire corrosion test. And these two tests enable a holistic view of the corrosion process and also provides the assurance that lubricants which perform well in these two tests will be much less likely to suffer real-world failures in electrified devices that they're supporting. So we'll first talk about the CDT, the conductive deposit test, which is the formation of deposits that electrically conductive and is obviously problematic in electric vehicles, motor designs. It creates pathways to stray currents to flow away from the intended route and lead to immediate failure of the device. The CDT, conductive deposit test, provides a quantitative measure of conductive deposit or conductive film formation as a function of time and temperature. It evaluates the potential risk of hardware failures caused by the deposition of conductive corrosion products on the electrical components. The technique is having a specially designed PCB board with gaps that are go back up again. That are got critical gaps that are between copper traces that are powered by 5-volt DC signal that are supplied to the voltage loops, 2 different voltage loops of the PCB board. Here's an example of the PCB board. You have the bottom loop and a top loop, and each of those are charged with 5-volt DC signals and monitored, and they're separate. So the bottom loop is in the liquid phase, and the top loop is in the vapor phase, the vapor state. So you're recording both of those. And this PCB board is lowered into approximately 20 mils of test fluid, and it's at 150 degrees C right now. It's the test temperature that's part of the method. It can run other temperatures as well, but the precision of the method is based off of 150 degrees C, and it's approximately a 500-hour test. So it's a long test, but that's what was needed to ensure that conductive deposits will, if they do form, they do form at that time. And it's in both the liquid and the vapor phases you're measuring, you're monitoring. And you're looking at the rate of change in resistance. And that board is placed into the instrument and then lowered into the bath. And that red piece in the middle there is where the board is positioned and connected to, which then lowers into the bath where your sample is. Here's an example of a failing board as well as a passing board. So it can get pretty corroded depending on how corrosion resistant your antioxidants are, your formulations are in your fluid. So here's an example of the CDT test result. You got resistance in ohms over time, and you're recording the oil resistance as well as the vapor resistance. So you're recording both of those that are under voltage and tracked over time. So when the deposits form or dendrites form, they actually short circuit those traces that are in that that PCB board, and that then causes a short, and that can damage your motor or your motor windings or whatever the device is. And the cumulative summation of the rate can be computed by what we call a conductive deposit factor, a CDF. And that will be in part of the, probably a part of the specification, the OEM specifications, because they haven't set the limits yet. The OEMs have not. We're working with them now to set the limits, but right now the test is included into the specification, just no limits yet. But it'll be a conductive deposit factor, which is that cumulative summation of the rate of resistance over a rate of change. So the other test, the wire corrosion test, the WCT, is going to be using the same basic equipment as the CDT, especially the lower half of that, which is the bath. The only thing that's going to be changing is, not sure, there, is going to be this top recording head. And we sell these in groups of 4 on one docking station. And then the docking station is then connected by Ethernet, can go to your LIM system. And these are all controlled with a iOS app that goes onto an iPad that comes with the instrument. So they can be individually controlled, all 4 of these on one docking station. So by changing the head, by changing these heads, you can go between CDT and WCT. So we'll talk a bit about the WCT test, which enables a quantitative and mechanistic evaluation of the corrosion tendency of a liquid or a lubricant in both the solution, once again, in both the solution and the vapor phases. And it's over a wide range of temperatures, but between 80 and 150, but it's been come down to the ground on about 130 degrees C, as opposed to CDT's 150, WCT is going to be 130 degrees C. So the oxidation and ensuing chemical reactions can cause depletion of the critical copper components, such as the motor windings and the interconnects within the EV powertrains. And this is very similar to the CDT, but it's also 20 mils of fluid approximately. And the popular test conditions, I had mentioned 130 degrees C. Instead of a 500-hour test, the WCT test is only 72 hours, so about 3 days. So it's a much quicker test, quick turnaround. And the test board, once again, has the separate wired loops, both in the vapor and the liquid phase. And it has a constant low voltage current applied to the test wire. So what you see here is it's not a PCB board, but this is an actual board that is wired with the copper, very thin wire, copper wire that's wrapped around this board. And that's what you're placing down into the sample. Once again, at the your sample level of 20 plus mils, 22 mils, I believe, is going to be about right in the middle here. So then you have your liquid phase and your vapor phase. So the test temperature and the duration with this can be varied to determine corrosion rate as a function of temperature and time. So also the wire material can be varied as well to analyze effects using other desired metal substrates. Heard of tin and aluminum, even gold. So you just need to get the wire. You can wrap it around this board, and you can test it in the instrument. So it's quite versatile as well. And here's a picture of the unit assembled. So it looks just like the CDT, just a different head. So here's an example of the copper conductivity loss, because you're actually looking at the wires actually changing diameter. So the atoms of the copper allowing conductivity of electrons. So as you lose copper, you have a higher resistance as copper is being lost. And as the reaction of the copper also is higher resistance. So copper loss due to corrosion increases the rate of resistance. And the actual wire outside diameter is physically affected by that. So that's kind of what you're measuring in angstroms. That's what you're measuring that in. So here's an example of copper loss in angstroms over time. So you have a very quick, a poor performing fluid here with your copper that's being dramatically affected, but yet here it's a very well performing lubricant or fluid, and it's not affecting the copper wire nearly as much. So the rate of change in copper loss over time is monitored continuously throughout the test. So industry status. The conductive deposit test, CDT, earlier this year was given D8544, and the WCT, wire corrosion test, is currently being balloted at ASTM D2, and it's being balloted currently and should be completed within the next month or so. So by December, we should have a ASTM test method number for the WCT. It's already being written into the U.S. Army mil specs, FTM, and just awaiting approval. It's included into being included into global EV specifications from different OEMs. We're working with them quite often, and it already is included into the SAE J3200 for electrified drivetrains. So this is just some brochures that we have that goes through all of our different instruments that we have at the booth. Booth 57, the IPSA IPSA booth. So with that, I think I made my time. Are there any questions?
We have 3 minutes for questions. Any questions for Gordon?
Well, it was pretty good timing, wasn't it?
Yeah.
I had no idea how long that was going to take.
So while we're waiting for questions, are there any questions? Let me just ask you real quickly. These tests are U.S. tests, right? Or are they also being adopted in Europe? The CDT and the...
Yeah, good question. To my knowledge, no European OEMs at this point have specifically mentioned them. But they will likely be in IFC coming up. I think the GEO4 specification is for EVs, or GEO5. And there are European OEMs included into that.
Okay.
So it may not be in their specific OEM specification, but it would be from, for instance, IFC.
I was just wondering, Gordon, if the European OEM concerns are different from the American OEMs when it comes to electric vehicles.
Yeah, well, we work with laboratories over there, the testing laboratories, 2 big ones there in Germany, and they are running this test, and they have their own tests as well, but they are very, we have a liquid version of these tests that we don't sell. It was just kind of given to a few labs to evaluate and run. These instruments here have not been produced just yet. Later this year, they'll be shipped. But they will be buying these, and I believe that's going to be to help support the OEMs in Europe.
So maybe it's more of an in-house test rather than industry specification.
In Europe, you mean?
Yes.
Possibly, yep. Unless they start adopting it more, they see the value in it.
Okay.
So.
Any other questions for Gordon? You get a prize if you ask a question. I'm not bribing you. Actually, this is a very interesting subject. It's very technical, and I know maybe it's a little bit new to the market.
Yeah,
so
it's been presented by Greg and several from
Yes.
Lubrizol, Greg Hunt as well from Lubrizol, in last 3 or 4 years. But it's slowly being adopted. I mean, we're slowly understanding, because the CDT and WCT are the only 2 tests that we know of that has been specifically designed for the EV fluid market. All the other ones are just kind of like already used, the foam and all these different tests. So these are specifically developed just for EV fluids.
Yeah, and if you have questions later, maybe you can drop by at the IPSA booth. Are you going to be there?
Yes, all week.
Okay. Well, thank you so much, Gordon, for
Great.
your presentation.
Yeah, thank
Very
you, Vicki.
interesting. Thank
Yep.
you.
Thank you.